Hi, this is Subramanian Venkataraman. The title of the project is Real-Time Sentiment Analysis on US Presidential Nominees using Twitter. To give introduction about the project performs sentiment analysis on US presidential candidates Hillary Clinton and Donald Trump. The public data is captured from Twitter using Spark streaming and Scala and loaded into Cassandra DB locally. This captures data from Twitter for the keywords Donald Trump and Hillary Clinton. Then we also run R programming, which passes the data loaded into the Cassandra DB, performs sentiment analysis, and calculates the sentiment analysis count for in the form of a line graph or bar graph carried out by program which is uploaded in Shiny App Server. We are going to see the demo of the execution at the end of the presentation. Sentiment analysis. Generally, organizations use sentiment analysis to understand how the public feel about a product or a person or a campaign or any marketing strategies. So this is very important because now social media broadly used by every industry around the world. So people are immediately tweeting their opinions about each and every aspect of whatever they encounter during their day-to-day life. So what the marketing people have started doing right now is they started focusing on the social media in order to understand what public feel about my product, my campaign, or my organization strategy, or the support I'm extending for the public in a particular sector. So I want to know about what people feel about me, what people tweet about my services. Everyone starts focusing on the social media to understand how they are performing. This is used for two different purposes. One for self-analysis and marketing analysis, or for any R&D purposes to how to improve our strategy further, how to support the people. So this kind of analysis really helps the industry to improve their services in a better way. Why social media? This is what we discussed right now. Social media analysis can be used for determining the marketing strategy, improve the campaign success, improve the product messaging, and improve the customer services. Generally, we are using machine language programming, using Python or any other tools. Those tools are really helpful in capturing the data and performing sentiment analysis on each and every data that is generated. When you pass the data and when you apply any libraries to find out the corresponding emotion of the public for a particular tweet or particular message, that can be classified further into happy or sad or angry or disappointed or surprised, proud, in love or scared. So these tools have evolved so much to find out what exactly public feel about a particular situation. And tools are also have evolved to categorize them based on various emotions. The project aims at capturing the sentiment data from Twitter about the Republican candidate Donald Trump and Democratic candidate Hillary Clinton. The Twitter is searched for the keywords Trump and Hillary. The tweets about Trump and Hillary are captured and saved into the database. The sentiment analysis is done using R and published in Shiny dashboard. So this is about overall strategy of the project. Then analytics and reporting part. The data is analyzed for positive words, negative words, and various emotions using a data dictionary. In our case, we are using an org library using which we are able to figure out sentiment aspect of the particular keyword or a particular statement or particular sentence. The special keywords such as acronyms, emotions, emoticons will also be considered for grading the user opinion. The results will be summarized and generated in the form of a graph to review the performance of Trump and Hillary Clinton against a set of emotions. The phases. Now we have to understand what phases are there in this project. The first one is content retrieval. The Twitter data is collected using Spark Scala streaming API. The captured data is stored in the Cassandra DB locally. Then what we need to do once we have the data captured from Twitter using Spark streaming, which is available in our Cassandra DB locally. So what I need to do next, I need to process the data. How I am processing the data? I'm using an R language using which I pass the data and apply sentiment analysis for the pass tokens. Now, once I apply a sentiment analysis for the past tokens, what do I get as a result of it? I get these sentiment counts for in favor of Hillary Clinton, against Hillary Clinton, or in favor of Donald Trump or against Donald Trump. So this sentiment data counts consolidated against every second for each of the candidate and loaded into MongoDB cloud. Next, we need an analytics program that has to capture the data and it should generate real-time reports like in the form of a bar graph or line graph to indicate the positive and negative sentiments of the public. Sentiment classifier. These slides discuss about what kind of tweets are there. Positive tweets. Positive tweets are the tweets which show good or positive response towards a subject. Example, Trump is doing awesome. Or I like the Hillary's educational assistance program. So these are all positive tweets. These are public's tweet about their sentiments in the Twitter. The negative tweets. Negative tweets can be classified as the tweets which show a negative response or opposed towards the subject. Example, Trump is not giving respect to Senator John McCain. This is an interesting statement. Or the other one, in the case of Hillary Clinton, I don't have confidence in Hillary's policy for defeating ISIS. This is another kind of statement. So what it indicates, these two statements indicates negative public sentiments on Trump as well as Hillary Clinton. Then neutral tweets. Some tweets can be neutral, that can communicate a message. It will not oppose or it will not be in favor of a particular subject. An example is Trump is visiting Mexico to meet the president to discuss about the border wall. This is an interesting statement, but does not indicate anything about positive or negative on Trump with respect to this topic. Then architecture diagram. This slide discusses about the architecture diagram. Here the Twitter data is downloaded using Twitter API. This area is a Spark engine which has got a Twitter API and Spark streaming programming. The Twitter data is available in the cloud, right? When the Spark engine runs Spark streaming program which connects to Twitter data using Twitter API, and the data is captured and stored into a Cassandra DB locally. Then we have a R parser server which continuously runs in my local system, which reads Cassandra DB and performs sentiment analysis and captures the sentiment count for Hillary Clinton, Donald Trump, and stores into MongoDB in cloud. Then this is nothing but analytics server, Shiny Apps IO server. This server reads the data from the MongoDB and generates sentiment analysis reports. When user connects to this analytics server, they can view the reports generated in the form of a bar graph or line graph for every instance of time. This is about the overall architecture diagram. The implementation using RStudio strategy here. After explaining about the architecture, but the same has been mentioned here. Close the snapshot here to indicate the UI design. This is the main introduction part. In the introduction part, we explain about the strategy, what we have done here. Then we have got a sentiment reports, line graph for every minute, line graph for every second, and bar graph for every minute, and line graph for hourly. It's slightly not visible. I will show you that. And developer, who is the developer? This is a sentiment report for various emotions of the public. This is a sample report we touched here for your reference. If you look at this slide, you can see the different types of sentiments like anger, anticipation, disgust, fear, joy, sadness, surprise, trust, negative, and positive. This area is for Hillary Clinton, each and every sentiments, and this part is for Trump, each and every sentiments. Here, if you look at it, positive. Positive is green here. Trump has got more positive tweets when compared with Hillary Clinton. Then if you look at the negative, negative is black. Even when you compare the negative aspects, Trump has got more negative tweets when compared with Hillary Clinton. So what it indicates is Trump is on the extreme side of positive as well as negative. That's what. This is what generally public feel about him when we look at his statement on every respect. When we look at the statements that is being made by Trump, he is on the extreme side, either on the positive or negative. This is a line graph generated for every minute, and this indicates the positive sentiment. This report was taken just 1 month before, mostly. If you look at it, red is for the Republican candidate, blue is for Democratic candidate. In the case of positive sentiment, Trump is leading every minute or every second. This is what this graph indicates when compared against Hillary. Also, if you look at the negative sentiment, Trump is again getting a more negative feedback on his policies and speech from the public when compared with Hillary Clinton. This is what the graph indicates. This graph is about positive sentiment every minute. This is a line graph for every second, positive sentiment. In the case of every second, Trump is leading. This for line graph every second, negative sentiment. Even in this case also, we can say that Hillary is leading. She is getting less negative sentiments when compared with Donald Trump. Now we need to talk about the performance of the app. The Spark Scala streaming process generally collects 50 to 80 tweets per second at the global level and is stored in Cassandra. In the sense, we are not given any location while capturing the data from the Twitter. We are reading just the specific keywords, Trump and Hillary. So it generates around 50 to 80 tweets per second. Within that, some of them could be positive for Hillary and some of them could be negative for Donald Trump, something like that. Then what we do, we parallelly run our parser server, which reads the tweets from Cassandra and it performs sentiment analysis. It considers only the data that is created only in the last 10 seconds. I'm ignoring the data that is created before because I don't want to duplicate the data. I just want to be very careful. Whether I can provide the data for a particular second, but I don't want to provide the data for a particular second with a duplicate information. So I am ignoring the data that is created 10 seconds before. Even I don't have to worry about that. In order to capture the data, what do I need to do? I need to run a Spark Scala streaming process as well as the R parser server in parallel together. Then when it runs together, there is a scope for me to read the data from the Cassandra that is created in the last 10 seconds without losing any of the data. This is my assumption. If there are any tweets generated before the 10 seconds, that is ignored, avoid the duplication. My focus is to avoid the duplicate, whether I'm giving a right data or not, whether even I could have missed out some data, but the data that is being produced should be accurate. That is my objective. So we are ignoring the data that is created 10 seconds before. The Spark streaming process and our server runs in parallel and the consolidated sentiment counts are uploaded into MongoDB in MLab. When the number of records increases in Cassandra, it creates a delay of 45 seconds for our parser server. That means
Spark streaming process creates heavy load of data.
And whereas the R parser server run in parallel against the speed of a Spark Scala streaming process. But generally it is not possible. The reason is when the Spark streaming process runs the program, the size of the database increases gradually. As and when the size of the database increases gradually, the load is faced by the R parser server. Due to this, certain records are omitted. Also, there is a delayed reporting on the analytical reporting side. That means the data might have been created at 1:45 p.m. 10 seconds. When I am running the R parser, what it does, it reads the data of 1:45:10 at 1:45:20. By the time it reports the data at 1:45:10 in the Shiny App server, in the Shiny Apps analytical UI, I'm getting the data of 1:45:10 at almost 1:45 50th second. That means there is a delay of around 45 seconds when the load increases on the Cassandra DB. This is the performance of the app at present. So what further improvements I can make on the project? I can introduce Kafka to avoid the omissions of data read from Twitter. Then another concept is introduce time to live, TTL, to eliminate the data from Cassandra server. That means I don't want to retain the data that is created 10 seconds before or 1 hour before, so that I can eliminate the load in my Cassandra DB so that it will help our parser to consolidate and report the results very quickly. So I'm planning to introduce a time to live option while inserting the data in the Cassandra database so that by specifying a particular seconds, for example, n number of seconds, after the nth second, the data will be automatically paused from the Cassandra DB. Then perform analytics using Spark Scala itself instead of introducing layers of R parser server. So what happens right now, I'm using Scala for downloading data from Twitter into a Cassandra. And then I'm using R programming, pass the data and report the analytical count or sentiment count into MongoDB. I'm using two layers right here. Instead, we can use Spark Scala itself while capturing the data from Twitter through streaming process. Immediately I should be able to do the analytics for the sentiments count, and I should upload the sentiments counts data directly into Cassandra or directly into MongoDB so that I can eliminate the process of using R parser server. This will help us to improve the performance of the project. Some of the references are also given here. Now let's look into the execution part of this project. This is my Spark program written using Scala. Okay. Now also I have opened data stacks. I'm downloading the data into data stacks right now. Let's count the number of records here. So, around 3,438 records are there. So what I'm going to do is I'm going to delete all of them. So that let's start with the fresh data. Now I'm again running the count. It shows 0 records. Okay, good. Now let's move on to R. This is my R parser code. This reads data from Cassandra. If you look at it, I'm using RC connect to the Cassandra. It's connecting to a demo DB, the key space. Twitter is the database. If you look at it here, demodb.twitter. DemoDB is the key space and Twitter is the table name. Okay, so this is connecting to this IP address here and reads the data and parses it. Then I'm calling the parse tweets method, which uploads the data into MongoDB. So this is what you are going to see here. Inserted one record into MongoDB at mlab. This method is nothing but process tweets. Process tweets is called for both Hillary Clinton and Donald Trump here, because after reading from the data and dividing the data into Donald Trump as well as Hillary Clinton for the messages that is created in favor of or against them, that goes to a Trump data frame. Same way we are creating the data frame for Hillary Clinton too. That data frame is processed separately one by one, and that final data goes to MongoDB with the sentiment counts. Okay, now as we said, we are going to run the Spark streaming program as well as R parser program in parallel. This is kicked off right now. Okay, now writing 0 rows. Now it started writing 30 rows, 48 rows to Cassandra. That means for every second it uploads around 50 to 70 records into Cassandra database. Now we are going to run the R code. This will run now. If you look at it, now it's reading the record that is created only within the last 10 seconds. It is inserting the records right now. See, it is inserting. Also, it provides me the sentiment counts, how many records are going in favor of Hillary or against Hillary for every sentiment counts. Now it goes to sleep. I'm keeping this to sleep for 5 seconds. Then again it runs. It captures the data, consolidates the data, and uploads into MongoDB again. Then it will go to sleep for 5 seconds. Again it will start after a few seconds. This is the total number of records uploaded so far. So now the message goes here. These messages are indicating the, it's a kind of debug messages which helps me to understand what happens when we execute the process. Now let's move on to the server. Reload. Now let's look at the sentiment reports. These overall sentiment reports. As we said in the graph, positive is green. Green is high for Trump. Negative is black. Black is also high for Trump. Now let's look at this every second thing. Now it is focusing on 9:25, 11:15:35. This is a date here. This part is date and this is a time part. So 23:15:35. This is supposed to change right now. See, now look at it. 23:15:35. This is a graph. 23:15:35. Then 23:15:56. That means we have lost certain data between the seconds. Between 35 to 56. And 23:15:57. Now it comes continuously. 56, 57, 58, 59, 60, 61, 0 to 03. Somewhere it loses the data, right? 23:15:57, 23:15:58, 23. Yeah, now it comes correctly. 1, 2, 3, 1, 2, 3. Then it has gone to 24. See, there is a gap. 23:16:02, 23:16:03. Then 23, 16, 24. That means we have lost the data for around 20 seconds in between. So this is the drawback right now. But anyway, we'll improve this further. Then this is a bar graph. This indicates the overall picture of positive and negative sentiments for the candidates. Here again, if you look at it, red. In the case of negative sentiment, Trump is also getting more negative tweets. Even in the case of positive also is getting more tweets in favor of him. So finally, it's social developer, contact info. This connects to my LinkedIn URL. Also, this option gives to send emails to me regarding if any comments. So this is about my project. Thank you very much.